too, the like chunkier jewelry and stuff like that. So,
Yeah.
and again, I don't think guys are gonna really know this unless.
See, yeah, this is what women go through. If you ever wondered like what women go through for a mock interview. This is a mock interview yet.
Yeah.
And look at us, we're all like trying to be nice.
Speaking of, how did it go for those who have done it so far?
It was good. I mean, I feel like I was definitely not all that sharp, but like I was saying before, you have to say things out loud, like, and get practiced at it. Otherwise, everybody just sort of, like, what's in your head, what you're saying in your head is very difficult.
Yeah.
Not that I say anything inappropriate, but, you know, it's just like, it's flabby, you know.
Oh, for sure.
And
Yeah.
there's always those awkward questions that get asked, and you're like, nobody would ever. You know, it's like normal conversation. So I don't know what my strengths or weaknesses.
I don't like those
They
questions.
ask me about my weaknesses, I'll rattle them off.
Yeah, that's-
Strengths,
yeah.
I'm like, what am I good at?
Well, they were asking me a lot of questions because, you know, it's like, oh, you're a lawyer and you passed the bar and you should highlight that. It's like, most places don't want to hear that.
Yeah.
So
Like
in
they're
my
overqualified.
experience, yes.
Yeah.
Right. So that's not a selling point. And it's been a long time since I practiced, so.
But they want to know that you're smart and you can learn.
Yeah, you did say that, but not all fields feel that way, so. A weird, like, code, and also here, I've noticed for coders, there are a lot of career changers, it seems like. And people are much more open about that, but that's like kind of considered a negative in many settings. So
Thank you.
it's something I necessarily want to highlight too much. But I mean, not that I don't want to highlight it, it's just I don't really know what to do, like always, so. You know. But if I ever interviewed with Raymore Flanagan, obviously I would be.
You know what to do.
Yeah, much better prepared, and I would wear a matching jacket and pants. Lesson learned.
Did you?
Well, I specifically asked because
Oh,
we
you
didn't say
actually asked
anything.
him.
I specifically said, like, afterwards,
Oh.
we were just talking, I
Oh,
said,
wow.
is this appropriate? Because it's really been a while.
Oh.
I mean, I feel like I look
I didn't
professional with
understand
that
that.
jacket. Yeah. No, I did, I specifically asked, I wanted to do that. So that's the only reason, but he was like, well, it's okay, but it's, you know, don't go any more casual.
Oh.
Okay, you know, but that was good feedback. I mean,
Yeah.
that's good to know. I don't think,
But did he explicitly say the not matching jacket?
no, he didn't
Okay,
mention that. but I
you're
think
just
that's what
like
he was-
trying to put it together.
Yeah,
Yeah.
I'm sure that's what he was referring to. But I think with the jacket, and the whole
But
thing,
your
I thought I
necklace
looked.
matched and that, I mean,
My
you're
necklace
pulling it
matched.
together. Like, it really pulls on.
Believe me, I did not take offense. I mean, I
Yeah,
specifically
yeah,
asked,
yeah.
and I was glad he gave me honest feedback.
Yeah.
But, you know, like, I think the first couple of days of this coding camp, I wore makeup, and I was like, they're gonna know what I look like soon.
Like, not anything.
Not my thing exactly. I mean, I will if I have, you know, if that's the job and I like the job, I'll do it, but it's
Yeah.
not like something I would automatically want to do, you know, obviously. Because everybody's walking in and it's like, oh my God.
So did they do it like a traditional interview and then give you feedback? after?
Yeah, then they give you their comments, which is really helpful. Yeah.
Nice. Well,
It's really short. Like, I'm used to much longer interviews and having time to like flesh out a whole
Right.
story and stuff. And no, like, say what you're gonna say and like,
It's more like
pick
an
what you're gonna
HR
say and
interview.
only say that.
Yeah, I feel like it was more like an HR.
and typically when you're interviewing for a software position, there's gonna be a couple. Like it's, so I guess, it seems like this is more of like a first round and not like a more a technical or like an on-premise.
Yeah, it definitely
Yeah.
wasn't a technical one.
Yeah, it's really.
Yeah.
But yeah, they were asking things, I mean, you know, like, what do you want to do? And I'm always like, I don't know, because it's only a week. I mean, I get it's like week 12. Yeah, but then I would know what to say, because I would know what I was
I would
doing.
say what the question was.
And which is why I didn't write cover letters, I was like, I don't know what I'm.
Yeah.
Yeah, and once you guys get to the next module, you're gonna start talking about something that's a little bit different than like front-end web page stuff.
Right.
'Cause-
So, and I have no
Yeah.
idea what that is.
Yeah.
So I was,
Totally.
and then he said, well, maybe user experience, and I was kind of like, was that a trap? Because I don't know exactly what the user experience person does necessarily. I mean, I know generally.
Yeah.
So I was like, trying to chat because I didn't want to use a term of art, which is what we call it. You know, a specific, it means a specific thing to the tech community that is
Yeah.
not what I'm thinking of, so I didn't want to go down that road, but
Yeah, good job.
Well,
they don't like that.
Okay.
yeah.
Really appreciate your honesty, so I thought it was really good.
I think it's probably as good as time as any to get started. People are going to be
Yeah.
coming and going. Hey, how you doing? So yeah, Jesse just told me to mention to you guys, take a look at this thing. I wasn't sure if he wanted me to like try to remind you guys when the time was, but I feel like I'm going to be really bad at doing that if I'm like walking around and doing stuff. So if I happen to notice that you're here and you should be there, I might mention it, but don't rely on me. Okay.
Where is it?
It was in Slack where it was. Terakai.
And then some of them had changed.
Yeah.
The locations are gonna change.
Yeah.
Oh, that's right, after a certain time, there's a sign up.
Atrium
actually.
at front. Okay.
I think it's just walking from.
Yeah.
Okay, now I don't know how to check Slack.
Okay. Cool.
Yeah, awesome. Okay, that's fine. Yeah, what's up?
Get this going here.
Yes.
Okay.
I made it.
Okay. Let's get serious.
You guys ready?
Oh, yeah.
Cool. So yesterday we talked about JSON. I gave you guys some exercises. A couple of you guys, or a bunch of you guys, turned them in, and I did my best to look them over. I said to many of you guys that if you want to chat about it, we could do that either during or after class. So that offer's still open. Find me, we'll chat. But overall, people were doing pretty well. Like it was, people were getting the whole JSON's in a string, it gets encoded, it gets decoded, you can do stuff with the JSON object thing. So yeah, overall, nice job. But today we're going to be talking about something called REST API design. It's a little bit different than the JSON topic we talked about yesterday, but really it's still in kind of the same realm. So when we were, all throughout this module, we've been making requests to HTTP servers. And this topic starts to get a little bit more into how those HTTP servers are laid out. And this is a little bit of a prerequisite to the next module, because the next module you're going to be making those things. But this was specifically laid out in the syllabus for this module, so I figured I'd kind of touch on it. So the important first distinction here is the difference between a website and a web API. So I said REST API before, and when you make a web request to something, you're making a web request to a server, but what it gives you back is often different. You get different types of data back. So maybe you might get back HTML, or you might get back JSON, or you might get back text. Typically, a website is something that is meant for people to read. And when the web browser makes a request, it gets back HTML. So for example, that's like the Careers in Code website. The Careers in Code website, when you visit, your web browser makes a request to careersincode.org, it gets back that HTML data and it renders it in the web page, and you're now looking at a website. A web API, it's meant for computers to use, and that's like a web server that you make a request to, and it returns back something like JSON. It returns back something that machines are meant to access. And the key difference here being that web APIs are for computers, websites are for people. And a couple examples of the web APIs are any of these module5.pk endpoints we've been using so far, well, most of them in this class. So for example, the ones yesterday, like the JSON one and the numbers one are great examples of that. And also the New York Times API that I presented you guys at the beginning of this week with. So those are both meant for machines to consume. Does that make sense? Okay. Yes, and we are going to be today talking about web APIs and not websites. So REST refers to the design of APIs and not sites because it's talking about the way that you access data as a machine, or the way that a machine accesses data on the server. And I should probably also define what API is, which I'm guessing you've probably heard thrown around a bunch, but API stands for Application Programming Interface, but that doesn't really matter all that much. What matters is An API is a set of functions or procedures you can use to access another system. Now, let me break that down a bit. Functions or procedures, so things like, for example, making an HTTP request. That's like a procedure you do, or something like calling a function in the web browser, like calling document.createElement. These are different ways that your code can interact with another system and cause the other system to change. It's like the interface that allows that to occur. So a couple examples. The New York Times API, you can get programmatic access to the New York Times data. You can make a request to the New York Times, a GET request to get all those top books, if you want to do the request we were talking about before. And when you make that request to the New York Times API, you get back a list of all the top books, and you can do with that as you please. That allows your program to interface with the New York Times. And that's what an API is. It allows you to do that. And similarly, APIs don't have to be based in HTTP. They can be like a function you call. It's still a way you interact with something. So in the case of like the DOM APIs in the web browser, you're making a function call to something like document.createElement. You call that function, and it interacts with the DOM, and it'll create something on the screen for you, or you can do sort of operations to the HTML page. So in a similar way, you're doing things in your code that then are affecting another system through this API. Does that make sense? Okay, cool. So maybe to elaborate a bit on web APIs in particular. So this is a subset of APIs that we were just talking about. Web APIs, they really are kind of a hack. They never were really supposed to happen this way. HTTP was meant originally for websites. And that works great and all, and it worked for many years. But people wanted to do more. They wanted to make their web browsers interact and do other things on servers. The problem is, web browsers, they only speak one language, HTTP. So if you want to interact with the server in some way, you have to do all of that over HTTP. There's no sort of other way you can communicate. So what people started doing is they started kind of co-opting HTTP and saying, okay, well, instead of using it for returning HTML, let's return JSON. Instead of maybe always making GET requests, let's do things like making posts or patch or puts or deletes. And we're going to talk about all those other methods in a second, but making other types of requests. And by doing this, it means that now effectively you've created this mechanism to communicate, and because it's HTTP, the web browser can do it. So it's kind of become a standard because of the forcing function that the browser can only talk over HTTP. And over time, especially as the web's evolved, people have come up with lots of different ways to organize this. Because originally, like it was the Wild West. People just did whatever they wanted. And over time, with people playing around, they discovered things that worked well and things that didn't work well. And we're going to talk about REST. REST is a pattern that a lot of people have used that works pretty well. And it's kind of, these days, the industry standard way to do things. But just a couple different variables of things people have played around with and tried. Methods to use. Get and post, or more than that. So maybe we've only really used get and post in this class so far, but there are more methods, and maybe you want to use those in your communication. Or how do you structure your paths? Like if you want to get a list of users, do you make a request to /user, /users, /user list? There's all these sorts of naming conventions that get talked about as well. And then also, what kind of data types do you want to send? If you want to send data to the server, what are you going to encode it as? JSON, XML, something custom, maybe even include it in the HTML code and send HTML to the server or something. I mean, they're all valid solutions, but just some people have tried and been more successful with than others. So this brings us to REST, and REST stands for representational state transfer, which is, I guess in a roundabout sense could be understood. You're defining how state, the data that's being sent between two systems, is represented. Is it in JSON? Is it being sent with post, with get? Is it not even using HTTP at all? And REST in general is a set of these principles, a set of these opinions that people have come up with over time about how exactly you should lay out all the different requests that are made from a browser to a server. Does that make sense? I see maybe some confused looks. Although I'm not wearing my glasses, that could be the problem. I can just kind of see blurs. Okay. Yeah, I gotta put those on sometimes.
Yeah.
Being a software developer, your eyesight goes off a cliff at some point. Like, I'm sorry, but it's just gonna happen.
I assume we all get carpal tunnel too, so.
Some people really get into the whole ergonomic working thing, and then they don't. Like Gus, actually. I'll take a picture of Gus's setup at work tomorrow and post it to the channel. He has like a split keyboard, a vertical mouse, like the wrist rests. Yeah. Yeah,
It's painful though. If you've ever had carpal tunnel, I had it during pregnancy, so it was short-lived, but it really hurts. Yes, I got everything bad.
Anyway.
But it really hurts, I just had to say.
Okay, I'll take your word for it. Anyway, so I guess so far we're just kind of doing an introduction into what a lot of these terms mean. But now we're going to kind of get into the meat of it. Like, what are these sorts of rules that are often followed when people make these endpoints? There's a bunch of them. And to tell you the truth, and hopefully no one that I know is listening right now, but a lot of these I actually had to look up because I didn't know their names. And I've just learned them by looking at other people's stuff and imitating what they've done. So to tell you the truth, some of this is going to be kind of new information to me too. So how about that? Yeah, so these are best practices. Think of them more as guiding principles. And they're the sort of things where like they're a good thing to do by default, but you'll run into situations where you just can't do them. And if you can't do them, like, cool, you can't do them, it's fine. But it's a good thing to start with, at least. Okay, the first thing, REST defines this concept of a resource. Now, what's a resource? A resource is kind of like a concept, which is like a super vague thing to say. But it's like if you have an API that's like for an automotive dealership, some concepts you might have like cars, you might have like salespeople, you might have like purchases, and they're all different kind of concepts that all interrelate. So maybe salespeople, maybe like cars are related with purchases. Like you have a car, it's purchased, you create a new purchase when you purchase a car, and maybe there's a salesperson linked to each purchase or something like that. But all these sort of, whenever you access anything about one of these resources, you always use the name of the resource. So all your paths will have that resource in it. So like, for example, if you want to request a resource, you might make a request or request a list of resources. You might make a request to slash sales, and you could get a list of all the sales, or like slash people, and you can get a list of all the people or something. But in general, by taking all of your functionality and effectively putting it underneath this sort of resource concept, it allows you to predictably know where things are going to be. Also, resources are always nouns. So like, you shouldn't have a resource of like running or something like that. Like, that wouldn't work. You might laugh, but people try to make that happen. Like, if you guys have ever done any sort of Java, you might know what I mean, but I'm guessing probably not, so never mind. Okay, so the first main philosophy that goes around with resources is CRUD, or what the technical term for it that I learned this morning is uniform inheritance. And that is that CRUD stands for 4 things: create, read, update, delete. And whenever you have any sort of resource, these are usually the 4 core operations you need to do to that resource. And if you think about it, if you have a bunch of things on a table, a bunch of like maybe playing cards, and you have a current state of those playing cards, you've got a bunch laid out, and you want to like get to a new state of those playing cards. Maybe you want to, some are going to be added into it, some are going to be removed, some are going to be modified, things like that. These sorts of 4 operations, you can use these in a row to get between any state you're at to any state you are. So maybe to give that an example, if I want to create, if I have one state where I've got a bunch of cards and I've got another state where I've got a bunch of cards with one more, how I get between the two is I create one more card. If I have a state where I've got a bunch of cards and another state where there's a card that's missing, I delete a card. If I've got a state where like I've got a bunch of cards and on the other one I've got a bunch of cards, but one of those cards is a different color, I modify the card or I update the card. So in effect, every single item, every single instance of a resource you have, like every single user, for example, you can create a user, you add a new user to the system, You update a user, you modify details about the user, maybe like their name or something. You delete a user, you remove them from the system. Or the other one, read, you just see if the user exists, get its information. But with those sorts of 4 things, usually that's how you, with a resource, interact and like take information and update it on the API. Does that make sense?
Would you say a resource is kind of like a prototype?
What do you mean by prototype?
Because the prototype is kind of like, oh, this is the animal, but there could be different instances.
Yeah.
If there you have a car, there's different instances.
Yeah, definitely. So if you have a car resource, you can have a bunch of instances of it where like maybe that car resource is one that has a brand of like Volvo, one that's like a brand of Ford, or something like that. And they all are of that same kind of resource. And whenever you want to do anything to that collection of those instances, you do it through the resource. So like maybe you want to update all the ones, you want to update the one that's Ford, for example. Maybe you make a request to /cars/Ford or something like that. And that would talk to the one that's the Ford one. I'm being a little vague right now because I'm going to talk about in a second the actual URL you use. But in effect, everything under that resource prefix is affecting all the instances of that resource. Okay. So yeah, how are CRUD operations normally implemented? So create, read, update, and delete. You have these 4 sorts of forms. And if you guys are writing things down, this is a great thing to write down. Whenever you create something, typically the method you use is a post, and you just post to the name of the resource, like post/cars, for example. And this is we've got our car collection here. If you guys didn't notice, we've got a bunch of cars. We're going to create, read, update, and delete them. That's a sort of thing that this API does. So if we want to create a car, we make a post to /cars. If we want to read a car, we make a get to /cars. So, or we want to read a list of those cars. So in general, it's similar to like what we were talking about earlier, where get doesn't have a body. You're making a request to get all of them that exists, and you're making a post request to it to add one. So post is pushing the data to the server and get's getting it back again. So those are methods you've seen before and we've talked about. But the update and delete one, those are a little bit new. So there's 2 other methods that we haven't touched so far in our study of HTTP. No problem. And that's put and delete. So the put and delete act just like a post. You can have a body in them if you'd like. And a put you usually use if you want to update something. So if we have an item in that cars resource and we want to update it, we'd use the put method. And then delete is very similar. So if we have an item in that resource collection we want to delete, we'd use the delete method to do it. So the other important piece here that I'm kind of skipping over this whole identifier for car thing. So far, I've been talking about the methods, like the methods you use for create, read, update, and delete. But the paths here, I haven't really gone into as much. And the reason why is when you create something, normally in the body of that post request, you put some JSON. And then in the response, you get back that JSON, but it usually has one extra key in it. Something like ID, or maybe it's like UUID or GUID, or there's a bunch of ones that can be, but normally it has ID in it somewhere, and that stands for identifier. And the reason why that's given back to you is because that effectively acts as a thing, as a value you can then use in your further calls you make to say, I want to operate on that instance of the car. So if I make actually, I think I might have this the next, yeah, I do. So if I make a car, I make a post request to /cars, and I include this data. So let's say it's got a company and a model name, and my company is Pontiac, and my model name is Vibe. I might get a 200 back, or something to 200 starting back, and then I'll get in the response this ID field here. And now that I have this 342 ID thing, whenever I want to, if I want to update this, I would make a put to cars 342. So 342 came from the post you made. And I can make a put to this cars 342 and put the data in here that I want to update. So I want to update the company to be Ford, and now the company is Ford. So in general, the sort of ID concept in there, you'll talk about it much more in the next module, but it's a way you can represent each instance of that resource as a concise, small thing that you can put in a URL.
So you're not typing out like a full word, like bunch of words.
Yeah. So just maybe if you think about it, how else would you represent it? There's other data in that sort of resource, but like there could be two resource instances that have the exact same data in it. You could have two that have Pontiac and Vibe. So you can't say like I'm going to just say I want to update the one with Pontiac in it, because that's not a guarantee. So the thing about this ID is it's always unique. Each one's going to have a new ID each time. So when you create something, you know this ID always refers to this thing and nothing else. Okay, cool. So that's kind of create an update. I skipped over read here. This one's a lot easier. So if you just make a get request to /cars, you're just going to get an array of all the cars you have. So if maybe at the very beginning of this, I made a / to get cars, I might get back an array with nothing in it. And then I make a request here to create a car. I make a request to post cars. I create it, and then I make another request to get cars. I'm going to get back this object in this array here inside of the response.
I have a question about updating.
Yes.
So you type out the put statement, the accept, the content type, whatever,
Mhm.
and you type out that object,
Mhm.
and then if you're just like, say you just wanted to add like the year to
Mhm.
it, right? Do you have to type out the whole object and then add the year, like what replaced the whole object, or do you just type like the one part you're trying to add?
Great question, and it's API dependent.
Okay.
Oh, that sounds
Yeah, so I will say that the official REST specification says if you make a put, you're supposed to include all the fields to update.
Because it'll replace whatever you put.
Exactly. But there's actually another action we're not going to talk about here called patch, and the whole point of that is
That makes sense.
it's like a partial update.
Yeah.
But a lot of APIs will make their puts into patches effectively, like make those two methods do the same thing and do what the patch method does.
Okay.
That makes sense?
Yes.
Okay. Okay. So read, this should be pretty simple. Get a list of them. We're going to do a bunch of practice on this in a second, so don't worry. And then delete. Delete's also not too bad either. So delete, you delete you make a delete request, pass it to the /cars/ its ID, and they'll delete it and give you back a 200 response.
What if you want to just delete one thing inside of it?
Define it.
What if you just wanted to delete one value?
Oh, like one of the keys inside of each one? Then you'd want to do an update.
Oh, okay.
So that's where having the whole
That makes
put
sense.
doing the patch thing is a bad idea sometimes, because if it's a
Right.
partial update, you can't remove it, because if you omit it, it's just going to it's just not going to update that field.
Gotcha.
that's weird.
So you'd have to like essentially delete it.
Yeah.
You'd have to
But-
delete the whole thing and then.
In practice, the fields you have inside of one of these things, those fields really, you don't want to add or remove them like it's a constant set of fields. So what you do more often is if you want to maybe unset a value, you set it to something like null or something like that. Or there's like a defined value that's like an unset value. In the stuff we're going to do today, I don't think I have that enforced because I just wanted to keep it easy, but that's typically how it works. Okay, yeah, so why do we follow these rules? It's like, they probably kind of make sense roughly to you guys, I would imagine. Like it's the way you update these sorts of things on the server. But what if you just like, why should you follow these? Why shouldn't you just come up with something on your own that's more concise and built for what you're trying to solve? And the reason why is predictability. Any software developer who sees this sort of structure knows it, because pretty much these days, if you're a software developer, you have to be familiar with REST. It's just kind of the way things work. So if you do things this way, anyone else can see what you're doing and help you immediately because they know how it works. But just like I said before, this is the best practice way. There's always special cases or things you need to do that are a little out of the ordinary. And there are actions that come up that don't fit into the whole CRUD paradigm. like for example, let's say you want to express that a car has been sold. That's kind of, I mean, you could maybe do that with an update, and you can like update something on the car. But often that sort of action of selling has more implications than just updating the car. Maybe you want to create a purchase or something. So having that just be an update is a little bit weird of a thing, because normally an update just updates something. It doesn't have like extra effects on other things in the system. So what will often happen is when you have these sorts of weird extra side effect things where you're doing extra stuff you don't necessarily doesn't necessarily fit into REST, people just kind of make it up. Like there's not a great like thing, a pattern people follow. I would say that it's one of those things where as you start to see more of it, you kind of start to get a feel for how people do it. I would probably make this a post because I'm like creating I'm creating something when I'm selling. So it's kind of like that would follow. But like there's no official REST rule on that. It's just what I felt that this morning when I was writing this. So yeah, I mean, you'll definitely run into situations where pure CRUD isn't going to work. And to add one more level to this, you can have nested resources in REST. So we have here like a student's resource, like we can create but we can also create an assignment to that student in the student's resource. In this case, we're saying like we've got a student, the student's ID bit, and we're creating an assignment. Or reading an assignment. And effectively, if you look at this, pretend this bit isn't here. And you still have the same sort of thing we had before. It's just now there's kind of a prefix before everything of the student's ID bit. And this, I don't know if you run this in your exercises tonight or later tonight, but it happens. It happens. So I just wanted to mention that in case it comes up. Also, I didn't check in. Any questions you guys have? I realize you haven't done anything yet, so there's only so much you can really have at this point, but anything come to mind? Okay. Cool. So now I'm going to talk about a couple things that often happen on reading things. So when you read a resource from a server, there's two things we've talked about so far. If you want to read a resource from a server, you can get a list of all of them with, yep.
Sorry to interrupt.
Yeah, no problem.
You can't see anything on Zoom.
Oh, oops. Did I forget to share my screen? I did. Sorry. Wonder if Jesse was. Oops.
Yeah, she's
Okay. I think I should be good now. Zoom's such a pain to like configure just perfectly, so feel free to yell at me if I screw it up. Anyway, so when we have these sorts of reads, with this sort of idea here, we're getting a list of all the cars. Now, often you don't want to get a list of all the cars. Maybe you only want to get the cars that are made by Ford, or the cars that are made by Pontiac, or the cars that are, or maybe the cars that are red, if that was a field in here, or something like that. So APIs usually give you the ability to do things like filtering. Like you could say, give me back a list of everything that matches this parameter. And a great example of that is like with Google. You're typing into a search box and you hit enter, and it's giving you a filtered list of the whole internet in front of you. And the same kind of thing here, only instead of the whole internet, we're talking about this resource only. So typically the way this sort of thing is done is when with what's called a query parameter. And I'm going to go to this guy first. But we've talked about query parameters a couple times in this class so far, but I haven't really given them a formal introduction. More just I've like briefly touched on them a couple times. And you're going to run into them now a decent amount, I would say. Like it's typically the way when you make a GET request, you can include additional pieces of information with that GET request because there's no sort of body that's in that GET request. You can include them on other requests too, but it's one of those sorts of situations as well where I can try to tell you this goes in a query parameter, this goes in the header, this goes in the body, but it's like software developers just kind of have a place they put things, And as you do it once you do it a couple times, you'll get a feel for where a lot of these things go. So but things like filters often go in query parameters. And query parameters, they follow this sort of format. They start with a question mark after the URL, and you have the key, the name of the parameter, and then an equal, and then the value, and then an ampersand. The name equal to the value. So there's an ampersand that separates each of these things, except for the first one where it's got a question mark. So nice and there's like a lot of different ways you can represent key value data, and we talked about JavaScript objects, JSON objects, headers, query parameters. There's tons of them. And because they're all used in a little different context, and they were all kind of developed in parallel, and they all people don't come to agreements when they're making things at the same time. So this is another one of those things where unfortunately you just kind of have to learn them all, and it kind of sucks. But I can show you an example of query parameters being used in the real world, and I'm going to go back to that Google example I was talking about. So I'm going to Google hello world. If you notice, I can't make it super big. I'll paste this in Slack. But if you notice, there's a bunch of query parameters on that. I can also put it in Sublime Text from yesterday. So we've got question mark source equals HP, ampersand. EI is equal to this long situation here. Q is equals hello world. OQ is equal to hello world. All these sorts of things. So these are filters that they've applied when they're making this request. Now, it's a little different than an API. This is like a website, but they're following the same sort of format because developers like to be kind of consistent. But this is a GET request that's being made, and it's got all these filters in it. And then in the output, this is filtered to show only stuff that relates to hello world. So these are a couple more realistic examples. So that was Google, but this is more like what you're probably going to end up typing. Something like get/users question mark search is equal to Ryan. Maybe get all users that have Ryan in their name or something. Like the names for these parameters are very specific to the API, and you're going to find it in the documentation. There's no sort of standardization around this, just whatever people wanted that day. Maybe you'd have get/users limit 20. We're going to talk about what something like that would mean in a second. Or you can combine them. You can have multiple, just like we had in that other slide. So as far as query parameters, you guys have run into them before with a couple of the exercises, I think, before, right? No? Okay, well, cool. So I guess it's new then, but hopefully it's not too bad. So this kind of there's really the three types of ways you can specify data in HTTP requests, and this kind of wraps it up. I don't think there's any more. So there's query parameters, headers, and a body. GET requests don't have bodies, but every other request can have a body if it wants, and query parameters, headers, and the body are all used for different things. Query parameters, like the sorts of filters or sorts of things like affecting the scope of data returned. Headers are like metadata, like authorization or content type or something like that. And then the body is like the actual core data that's part of the request. And it's another one of those things where as you do it more and more, you'll just start to get used to that sort of paradigm. And it's often kind of questionable whether stuff goes in the header or goes in the query parameter. And when it's questionable, software developers just arbitrarily pick. You can probably sense a theme here with the software developers arbitrarily pick. We're all just disorganized and we don't know what we're doing. Anyway, so I got an example for you for filtering. Let's do that. Open up. I'm going to do some Postman because I think you guys like Postman in general. OK. It's as big as it'll go. Is that a good size, or do you want it bigger? Bigger? OK. Let me see if I can open up that other Postman that I was using before. Maybe that'll go a little bigger. Yeah, I know it's being deprecated, but how's that? Is that any better? I don't know if it'll let me make it much bigger than this. Yeah, I think this is about as big as I can get, unfortunately. If you're having trouble seeing, I'd suggest open up the YouTube stream. But sorry. Okay. Now, I have an endpoint I made called http module5.tk/users. When I make a request to that, so I make a GET request, this is a user's resource. I'm going to get back a bunch of user information. So like here we have Miss Lou Carroll here that has a favorite color of orange and is a health education specialist. How about that? But more realistically, I want to do an example with filtering here. So I have a filter I've added to this endpoint that I just know because I wrote it, but this would be documented in the API documentation for the user's resource. It would say there is a filter that you can apply called city. And when you filter by city, it'll show you all users that are in that city. So I'm just going to scroll down here, and I'm going to try to find a city like, I don't know, like Toledo. And I'm going to put a question mark, city equals Toledo. I'm going to add that filter to this query, and I'm going to hit send. I'm going to get back all the users in Toledo, which is one user. And is it going to let me make this bigger or not? I'll do this. But it's giving me back one user here. So if you notice the open curly braces there, I'm going to go down, and that's the closed curly brace there. There's a bunch of fields in there, all that this returns. But the important thing is the city here is Toledo. So this is given back. This has filtered the read of that user resource, given us a list of all the users that live in Toledo. And we could do this just as well for any other city. Like I think there was one I was looking at this morning, Virginia Beach. Did I spell that right? I think I did. If I run that, yeah. So now we got a a user that lives in Virginia Beach. So anyway, we can filter by different things like this. In fact, you could also use this filter. You could just say V, and it would give you all cities that have V in them. In this case, we have we've got two people here that live in the city that starts with V. So we've got one that's in Mount Vernon and one that's in Virginia Beach. Yeah. So anyway, that's kind of how filters work. And filters are usually a thing that only exist on GET resources in REST. So because I mean, if you had like an update, how would you filter an update? Like you don't have like a list of things to filter through. You're like targeting one user in particular in this sort of example. So it's not really a principle that works in that sort of operation. So anyway.
I didn't get that though.
You didn't get that? Are you making a request to module 5, the same URL I'm making a request to?
Yeah, but I just saw the mistakes.
Just take a quick.
I got it. Yeah, I had 2 backslashes.
Oh yeah. Okay. Cool.
Oh, it makes a difference too. Capital V.
Yes. It is case sensitive.
It looks through the whole word.
If it's so, it'll look through the whole word in either
and down to
case.
lowercase v.
But it's
Right.
So what this is actually doing behind the scenes, do you know the index of method in JavaScript? It's doing an index of, and it's seeing if that is not -1.
Yeah.
For whatever you give it. So anyway, that's filtering. And we're going to talk about one more thing that you can do on gets. Now, there are more things, but these are the two things that I think are most important and the things that are going to come up in your exercises. That's why I want to go over them. So let's imagine a scenario. Imagine you work at Wegmans as a software developer, and you get asked by somebody to return back from an API a list of data of all transactions that were made at Wegmans yesterday. Like there's an API endpoint for like the transactions endpoint. And when you get/transactions, you want to return all the transactions that happened at Wegmans yesterday. Now, Wegmans is a big, like, humongous company with stores like all over the Northeast and a little into the Midwest and the middle part of the country. Yeah. Anyway, but that's a lot of data. Like if you wanted to get the transactions for yesterday, that's going to be like gigabytes and gigabytes and gigabytes of text. So it's kind of unreasonable to ask someone to, in just one response, get all that as one big JSON array. So software developers have come up with a sort of way to work around this problem, and it is called paging. So paging, the idea of paging is you make a request to the server, and you give it two parameters, a page number and a page size. What you do is, if you make a request with a page number of 1 and a page size of, let's say, 50, it will give you the first 50 results. If then you were to put in the page size of 2, it'll give you the next 50 results, so the result number 50 to result 100. And then page number 3 will give you result the next result, so like 100 to 100. Well, I guess it'd be 100 to 150 or whatever it is. But I'm guessing you probably get the idea. But in general, you can usually alter the page size. So you could, in theory, if you wanted to just say, give me all data, you could make your page size something humongous and say to the server, give me a page that is effectively the length of the whole data, and it would give you everything. Now, most servers are going to have some sort of limitations around that, where they'll give you like a maximum page size you can set. At work, our maximum page size is 5,000. And if you try to go over 5,000, you get back a 400 in your request. It just says, error, you can't make a page size that big, try again. But you might also wonder, like, okay, so you're paging through this data. If there's a sort of process where you have to fetch these pages over and over and over, how do you know how many pages to fetch? And the answer is there's usually two ways. So the first way is usually when you're fetching pages of data, they'll give you some sort of parameter in the response. It's like, is there a next page of data available? And what you can do is you can fetch the first page, and then you can just say, is that value in the response true? And if it's true, fetch the next page. And if the one in the next response is true, fetch the next page after that. All the way going along the line until it's false, then you know it's done. So that's one approach. And that works OK. But some APIs don't do that for you. And they just give you a bunch of data and just expect you to figure it out. And in that case, usually what you have to do is you just have to keep fetching pages until it just stops working. Like it gives you back a 400. And you're like, OK, I'm done now. And now you have all your pages. And that means that on the client side now, you have to take all these pages and you probably have to like stitch them all back together often. Like if you have each page is going to have like its own array, you have to do something like attach all those arrays, like concatenate them all together again. Depends on what you need to do, but sometimes that sort of thing is required. So let's do a paging example here. This user's endpoint I was writing also supports paging. And if you notice, there is here a total key that maps to 2, a page key that maps to 1, and a next page available key that's false. So I'm going to get rid of this filter and rerun this just so we have some more data to play with. Because right now we've only got 2 records, so the ones that the city starts with V to play around with. So let's get a full list of users. OK, so I made a GET request to /users. So I'm getting the user's resource, getting everything within it. And when I do that, I get 50 results. So total is 50. And then page is 1. So I fetch the first page of data. And then next page available is true. So I know there's another page available in the future. So OK, that's cool. And what I can do now is I can tell it to fetch the next page of data for me. And the way you do this is found in the API documentation, like all this sort of stuff. But I just happen to know, since I wrote this API, the query parameter you want to provide to do that is page, and the value is the page you want to go to. So if I do like, if I can type too, if I could go to page 2, notice this first entry here is the surname is McQueen. Now when I run this, it's going to change. So I do that. Now the surname is Sturgis. So the reason why here is page number 2. This is the second page of that 50 long amount of users. I think the default page size I set was like 10 or something like that. This is probably like number 10 up to number 19 or something like that. But so there's still a next page available. So let me fetch page 3. There's still that. Let me fetch page 4. Fetch page 5. Now the page size is 10. It's got 50 in total. So the 5th page, we should be at the end of it at this point. So if I do page 5, yeah, so next page available is false, notice now. And we're at page number 5. And if I try to fetch page 6, all goes to plan, yeah, I'm going to get back no data because there's no page 6. We're out of data to get. So if I were like getting each page in a series, like I were making a request to get the first page and a request to make the second page and a request to get the third page, and I saw no data, that could be a signal to me to be like, okay, I'm going to stop fetching all the pages now, and I've got all the data. So in general, the point of paging is that the server can't send you an infinite amount of data in one request. You need to somehow break it up into smaller chunks. And paging is just a traditional or a typical way that that's done. That sort of problem is solved. Does that make sense? Okay.
But now can you change?
Your question is probably more.
Probably not, but can you tell it somehow to give you 100 results per
Yeah,
page?
there's often like a page size parameter
Right.
specified, which you could say, give page by 100, like make it 100 long, and make it like fetch page 1, and fetch page 2, and page 3.
Right. Can I do it in
Yeah,
Postman?
the parameter that you need to use, I think, is page_size with this API. And you have to give it a number. I didn't set a max page size, but if you do any bigger than 50, it's just always going to give you all of the results because that's all you can fit in that page.
So page_size 25.
Yeah.
Whatever.
Yep. It's like ampersand before that. So it would look like this.
Oh, and
Yeah, so if I, not that. If you go back to here, it's going to look like this.
oh, okay.
So we're specifying a second query parameter as part of this request. If I do that, got to make the page something huge. But yeah, so if you look through here, you should get 25 of those in there. And then if I do 2, that'll work. But if I do 3, maybe it doesn't work quite right. Okay, but it should work.
Curious.
Yeah, and typically that'll be capped, so you can't just make it infinite. But
Okay.
yeah, often you want to fetch by larger pages because you want to minimize the amount of requests you have to make.
Right. And that happens on all websites, like Amazon will give you pages. Something like SOPA and.
Exactly. Yeah, it's that exact same concept where you've got like that little pager control on the bottom, and you can click the next page. Yeah, totally. Okay. Anyway, let's move on here. Okay. So that was REST philosophy number 1, and that was the one I wanted to spend the most time on. There's, I think, 3 or 4 more, but they're all much shorter than that past one. So we just talked about CRUD, the way you can represent a resource with different requests to that resource that do creating, updating, deleting, or creating, reading, updating, and deleting CRUD. So the next philosophy here, philosophy number 2, is statelessness. So in strict REST, every single request you make should be stateless. At least in how I've been taught. And that means that the requests should not be dependent on each other. So what that means is if I make a request to, like, let's say, /users, like I make a get to /users, I expect that thing to affect users and not to affect anything else, and for that thing to not maintain some sort of state, like not to maintain like a cookie or something like that. Each request happens on its own. Each request does like one thing separately on that resource. So a counterexample of this is like cookies or sessions, where you are making a request and you get back a response, and you now have like a session that has like that set cookie header. You're maintaining a piece of state, and then the next request you include that piece of state into it, you're getting back a response. And that sort of state is maintained across requests. The reason why that's kind of a bad thing to do is because what it often leads to happening is for you to include data in a request and then get back a response. And then for data, or then when you make another request, for data from the first request to somehow influence the result of the second request. And this starts to mean that it becomes really hard to figure out what a request will do because you have to have the notion of what happened in the requests before it. If each one happens individually and separately, then you can think about the request as its own encapsulated thing, and you don't have to worry about what happened in the past. Now, the astute among you may remember that we were talking about authorization and tokens and cookies earlier in the week, and if you want to like authorize an API, or you only want to allow some people to access it, you're going to have to do this. You're going to have like a token or a cookie to say this user is who they say they are, so you can track them between requests. And that's one of those situations where pure REST isn't quite exactly how things work. Like REST it's like a set of best practices, and you often have to break this sort of thing. But you shouldn't break it unless you have a really good reason, like authorization. I would say that in general, you want to make your requests be as independent as you can. And if they can't be as independent as they can, you should have a good reason for it. Okay, and maybe as another example of why this is a good idea to have each request be independent like this, is because let's say you have a user and they've got a login count value. Like that's one of the things they have. And every single time they log in, you want to set that value. Now, one thing that could happen is if you have two increments, like you have two endpoints that increment things versus setting the thing, like if you have like a separate incrementing endpoint for that, you could run into a sort of issue where you have two things kind of fighting over that sort of login count value. As I'm saying this, I'm starting to realize this is a terrible example. I don't know what I was thinking this morning. Never mind. Shame on me. Yeah, I'm gonna get rid of that. Okay. Anyway, this is one of those things where it's just like a lot of these principles. It's not something you really will think about explicitly. It's something where if you just mirror what people do, you'll just do this naturally. Like you don't necessarily have to think about, you can make each thing stateless like this. If you just if you mirror some of the APIs we're going to use in our exercises in the next module when you're writing your own, if you have questions about how something is done, look at how someone else wrote that in their API, and if you mirror that, you're most likely going to follow these REST principles to a T. So this is more just to spell it out. But anyway, so philosophy number 3 is a sort of client-server separation. And this is kind of built into HTTP to some degree. You've got a client that sends data to a server, and the server responds back with more data. But what this really refers to in specific is that the data format that the client sends, the server should be able to understand. And the response the server sends back, the client should be able to understand. Now, the reason why you want that is because if you have a difference in what is sent and what is understood, you'll run into a situation where the client can send something that the server can't understand, and the server is going to blow up. And that's not good. Like, you want to have a shared language going on between those two things. And the other piece that's somewhat important here as well is as you start to modify a server, you need to make sure the data format that it accepts or that it sends stays consistent with what the client expects to send. So maybe to break that down a bit, let's say you have a server, and you make a request to it to maybe update a user. And you have on this user, you've got something like maybe the user's name. And you decide later on in your applications, that, oh, I don't need the name anymore. I'm just going to remove it from that resource. So just no longer have to specify the name anymore. And that's cool and all. But you still have this client out there that's making requests to the user's resource with the name attribute. And it's probably going to explode. Like, you're going to make a request to it. The server's going to say, name? I don't know what the name is. What's going on here? And it's going to give you a 400 back because you screwed up. And that's something you want to avoid because if you follow this sort of principle, you can ensure that any sort of data that the client is sending you're never making a backwards incompatible change. The client and server are always speaking the same language. Or if you have to, the server maybe is speaking a little bit more of the language than the client. But you should always have it so if you make an API endpoint and the client is sending data to it, unless you really know what you're doing, you shouldn't break it. Like you shouldn't change the data format it accepts or it sends back or make it incompatible. Because then people who have written code to talk to that endpoint, their code is going to be all messed up. Does that make sense? It's now, this is another one of those things where it's best practice. And I have worked on teams before where people did not care about this. And as the client side of this sort of thing, it becomes a real pain because you spend your whole day writing your code to talk to the server, and then the person running the server makes an announcement at the end of the day like, oh, hey, I just updated the data this thing returns, and it's completely different. And it's like, oh, well, there just went my day. So on teams, this is especially important. When you're working on your own, it's a little bit less important. Because if you're taking care of both the client and the server, you know everything that's talking to the server, you can change both at the same time, and it's not a big deal. But on teams, very, very important. Yeah, so you should not remove fields from what the server returns. And existing things that depend on those fields are going to break. But you could add things, like I could have the server add another field in the response, and the client's just not gonna use that field, I guess. Max will talk about that part more next module, I think. But in general, the sort of you want to keep the data format compatible is a really big takeaway here. Okay. Cacheability. Ooh, yeah. So we are going to talk about caching on Monday. Caching is a whole thing with HTTP, and the quick little couple-minute version of this is when you make GET requests, only GET requests, those GET requests are cached, which means if you make a GET request to a server and you get back a response, and you make the same GET request, the browser might cache those requests. So in other words, you might make the request, and it might say, oh, you just made that request a second ago. I'm just going to give you back the response the server gave you a second ago and not make the request because I want it to be fast. And that's going to be faster than I actually have to go out and make the request. And because of that, you often need to build your API to take advantage of this. And it's a REST principle, but we haven't talked about caching yet, so I'm going to get into this more on Monday. Just know that caching is a thing, and you have to work around it. Sometimes it's a pain in the ass.
So is it just if you do it like soon after, or is it say cached forever? Like how long is it cached?
It depends. The server defines that value. We're going to talk about that on Monday.
Okay.
But actually the short answer to it is it's a header in the response that like the server can send back and say how long the browser should cache this response for. Okay. So how you should feel about these principles. I'm really hammering this home. There are good defaults, but they're really not always going to work. If they're like principles you should try to follow. But REST kind of is a sort of idealistic world where everything is all like CRUD and all everything's perfect, and the world isn't a perfect CRUD-y world. Wait, CRUD? That's never mind. That was really bad. Wow. And it's not how the real world works. Lots of processes require server-side state. Lots of processes fundamentally aren't idempotent. Wait, I didn't talk. Where's idempotency? That was a slide in here somewhere.
It's in there.
It was in there. Oh, I just totally skipped over it. Okay. Wow. Yeah. This should be. I should briefly mention this. So, idempotency. It's a word that effectively means if you make a request, it should do the exact same thing each time. Like for example, if you have a function like that takes two values as its parameter, it's like an add function. It takes A and B and it adds those two things. Every single time you call the add function, it's going to return the same value, as long as you give it the same two numbers. With something like maybe, I don't know, like getting a list of all the, okay. But did I have an example here? Yeah, yeah, this was a login count thing. Okay, never mind. That was a bad example. If you're curious about idempotency, there's some good articles about it online. And just know that it's a word that relates to this stuff, and if you have to learn it later, you can definitely do that. I might get into it on Monday too. Yeah, okay. So how you should feel about these principles, good defaults, but the takeaway really is follow them when you can. If you can't, it's fine, but do it intentionally. Don't. The worst thing here would be to break the principles accidentally. And And lastly, I just want to give one more point about that. These are the sorts of things that you don't have to memorize these principles. You're just going to get used to doing this. This is more, I'm mentioning this just so you can take note of this stuff when you're doing your exercises, and so you kind of know how to do some of the exercises tonight. But as you go on in your developer lives, you'll just find that this is just the sort of the way things work, and you'll start to get like a spidey sense for when you do things badly. You'll be like, oh, this feels weird. And you may not be able to explain why, but you'll know it's weird. So anyway, that's kind of all I had for the talking part of this. So I have some exercises. I try to kind of follow the same format we had yesterday, because in general, people seem to respond very positively to that. I originally, for this module, wrote 3 exercises, and this morning I combined them all into one big document. So there's a lot of text in here, and each exercise is actually with a different API. And they're not using, the first 2 aren't even using module5.tk. How about that? Using something real. Although calling the first API real is maybe a bit of an understatement, because it's the Star Wars API, and it's an API that allows you to access information about the Star Wars universe. Yeah.
Did you look at that with Gaus?
Maybe. It's a pretty classic, like, getting started with APIs example. So I linked you guys to the documentation for it. And I think it probably makes sense to go through this first exercise together, and then you guys can do the other 2 on your own. But I'm definitely throwing you guys in the deep end with giving you documentation, I realize. And I want to do a lesson on that next week about how it's best to parse this sort of stuff. But a big part of being a developer is being thrown stuff at you about how to do something and just reading it and doing the best you can and trying and failing. And it's the only way to get better at that skill is just to do it. Like, I can give you some tips about, like, maybe some suggestions, but there's only so much I can really give you. So I realize it may be a little hard and there's going to be some struggling, but I'm here to help. Katie's here to help too. Will's maybe here to help if he wants. But yeah, we'll get through it. So I guess you guys want to start with this first exercise together?
Sure.
Yeah,
Okay.
Yeah.
Cool. Says the guy who just arrived.
Yeah, that's right.
Cool. Okay. So we're going to use a new API for this exercise, the SW API. SW API stands for the Star Wars API, and it's an API that can be used to access information from the Star Wars universe. Okay, cool. You guys can all read. But the first kind of thing, whenever you get a new API like this, the first thing you should always do is go to the documentation. Now, actually, there's really a step 0 too, which is if you don't have the documentation, either find it or ask whoever is giving you this API to give you the documentation. Because without that documentation, it's like trying to learn a language without any sort of learning materials. It's like you can maybe, if you know kind of how languages work, you can kind of maybe make some guesses and probably get it pretty close, but it's very difficult. And often, some of the hardest problems that you have to solve are when you are trying to figure out how something works, reverse engineering it without documentation. It's often like an unbounded process where it's just a lot of discovery you have to do, like just try a lot of stuff. Anyway, so exercise 1. Determine a list of all people in Star Wars that have a homeworld of Earth by making an API request to the Star Wars API. Okay, so when I read this, I see list of all people in Star Wars. So I know I want people or users or some sort of humans or aliens or some sort of entity like people thing. So I'm going to look for something like that in the documentation that have a homeworld of Earth. When I read that, I think, okay, they have a homeworld of Earth. That, to me, that screams filter in my head. I have a list of people. I need to filter by homeworld of Earth. And then by making a request to the Star Wars API, well, duh, that's kind of what we're doing in this module now, isn't it? Okay, so I'm going to look at the documentation now. And documentation reading, we're going to do a lesson on it next week. But in general, what I like to do to start with is I just kind of scan it. So I see like documentation, getting started, encodings, resources. Oh, I know what that is. Resources. In fact, I saw resources over here. Yeah, here's a list of all the resources in this API. And hey, look at that, there's a people resource. Oh wait, I just realized I need to make this bigger for you guys, sorry. So I'm looking through this, I see resources, I see this list on the side, I see there's a people resource. So I'm gonna click on that. A people resource is an individual person or character within the Star Wars universe. Determine a list of all people in Star Wars. That sounds pretty much like a match. Okay, so there's a couple endpoints here. /people, get all the people resources. So it sounds like a REST thing, like get a list of all the people. /people/ID, get a specific people resource. So if I happen to know the ID of one of these people, I can just look them up directly. That's kind of handy. So let's see, what do the IDs look like? Oh, okay, they're not going to give me, whatever. We can figure that out later. And this last one, I don't know what that is. I'm not going to worry about it. JSON schema, that's something we haven't talked about in this class and something that I'm even not all that familiar with in my day-to-day. Okay, then I see example request. And okay, so it's HTTP space whatever. I don't know what exactly format this is in. So we're just going to ignore that for now, but there is an example. That's the important thing to note. There's an example we can follow of like a request to make. And we get an example response. This looks kind of like something you guys have seen before. Like it looks like HTTP 1.0, 200 OK, some response headers, and then a response body that's JSON. So this just looks like an HTTP response. So that's very good. That's very good. Okay. So I see example request. I don't know what this is. So if I run into something like this where I don't know what it is, usually my next kind of step is I want to go back to the top or look for maybe some broader context on the API. So I see things like getting started. Okay, that's a good place to start. Getting started. How am I going to do this? So they say, let's make our first API request to the Star Wars API. Open up a terminal and use curl or HTTP IE to make an API request for a resource. So this is not curl, that's for sure. We've done curl. Curl's a command that it starts with curl and you type out a bunch of stuff. So I'm just going to make an educated guess. This is whatever this HTTP IE thing is. So I'm gonna go to this and see what the heck it is. Oh, and they are being clever. Attach a TPy. What? No. Freaking developers. Yeah, okay, so this looks like what this is. So this HTTP IE consists of a single HTTP command designed for painless debugging and interaction with HTTP servers, RESTful APIs, and web services. So between this description here and looking at this terminal thing, this looks like it's a thing very similar to curl. Like it's a command line tool you can use to make HTTP requests. But okay, cool. I mean, we don't really need to get into it any deeper than that. I've never used it before. I don't really know what's involved with it. But just knowing that's what that means, that's really helpful. So now we can look at these examples and we can say, okay, HTTP, this command, we know that this is making an HTTP request. It's using this HTTP IE tool, but we know it's making a request. I'm going to go back to this people resource here. So, okay. Typically, we had talked about things default to get. Like that's kind of the default method things use. So given there's nothing here that looks like a method, I'm just going to guess the default method is get. And that would also match with like the read idea. Like we're reading a list of people, it should be get. So I'm going to say that's probably a good place to start. So I'm just going to take this URL here, and I'm going to go into Postman. And I'm just going to make a get to it and see what we get. And hey, whoa, that worked. That's great. So we got back a JSON object. It's got name, Luke Skywalker, height, all this stuff. A bunch of films. Homeworld. Oh, wait, Homeworld. I think that was a thing that maybe was mentioned. I said Homeworld of Earth. Okay, that's interesting. So there's a Homeworld key on these people things, on these people resources. That's a good thing we should keep in mind. Okay. Also, I feel like I can scroll this. Yeah, that's why. Okay. Yeah, wow, Postman's kind of goofy. But so we got all this cool stuff. Sweet. But if you notice, this guy here, it's only giving us back a single person. It's only giving us back Luke Skywalker. And the reason why is this here, /people/1, looks like it's this one, /people/ID, get a specific people resource. I don't want a specific people resource. I want to get all the people, and I want to see all of them that have a Homeworld of Earth. I don't want to. I mean, I guess I could just like manually go like people 1, people 2. Oh, C3PO, people 3. But like, who wants to do that? That's pretty terrible. R2D2. Oh, hey, that's cool. So I'd much rather make a request and get all the people in one big request and then filter that big request instead of like going through manually for each one. So what I'm going to do is I'm going to change this. I'm going to alter the URL. It says this one's /people/ID. This one's /people. So I'm just going to go over here and I'm just going to get rid of that and see what happens. And oh, cool. Now we get a list of people. And this looks like it's using paging. There's a next. There's a previous. There's a count. So just because I know this stuff, I would see, oh, count. That's how many actual people there are. I know next, you see, oh, there's a page 2 query parameter in there. Oh, cool. We're starting to see stuff we talked about in the exercises. But if you notice here, like Luke Skywalker, C3PO, R2D2, we have all the ones we were running into, Darth Vader. So, okay. We've done the first part. We've been able to get a list of all the people. How are you guys following along with this? Does this stuff make sense?
Mhm.
Okay. You were.
I just walked in.
Yeah, you just walked in.
I'm like,
This is gonna be a fun class because like people are only catching like little bits of it. Yeah. So I'm very much expecting to do a lot of re-explaining, but that's totally fine. Okay. So we've got that. Now, the other piece here is I asked to get a where is it? Home world of Earth. So I'm gonna keep looking through this people resource here. So we got the endpoints, we got the description of it, we know it's called people, we got the example here, attributes, okay, interesting. Home world, URL of a planet resource, a planet that the person was born in, on, or inhabits. So I don't exactly know what they mean by attributes. Like that's not really something we've talked about. It's not really a standardized HTTP or REST thing. So I'm just going to just throw out a guess that maybe they mean by attributes query parameters, or maybe they mean like filters, because these kind of seem like they could be filters. Like I want to filter by gender, by hair color, by height. And the way this English is phrased is the URL of a planet resource, a planet that this person was born on or inhabits. That sounds kind of like it's filtering that list of like to people that were born on it or inhabits. Like it's not at all, like I'm not reading this. This is all just me kind of guessing, but it's how the stuff goes. Like you just have to make some educated guesses and see. And because I know filters normally look like query parameters, I'm going to try that out. So home world, let's try like just the obvious, like home world equals Earth.
So is it people question mark home world?
Yeah, I'll post this in Slack.
how do you know to do the question mark? Is that experience?
That's syntax. We just talked about that.
No, I'm not gonna ask questions.
No. Feel free to ask, but the answer might be we'll talk about it in a second. Okay. So I think I got a little lucky here because I've done this a lot and I just kind of know what I'm doing. But that seemed to do return data. Like I get back, well,
the value of homeworld
I don't know.
is a URL, not a word.
In here it's a URL, yeah. Let's see. Yeah, maybe this isn't right. So yeah, because we get the same number here. Like if we get rid of this guy, we get the same count.
If you look at all the URLs, there's numbers after planets. So like Luke has 1. If you go down, there's one with like a number 2 next to it, which to me seems like that's a different planet.
Yeah, that would make sense to me too. So let's see. The URL of a planet. Okay, yeah, let's do this. So given this is a URL, let's just see what that goes to if we go to it. Like maybe that Tatooine. Okay. So cool. I think that's I've never actually seen a Star Wars movie. So like I'm just kind of yeah. It's a long story, but I wasn't allowed to watch movies as a child. Anyway, but
I was the last in 7, 8, 9 to see Star Wars. Last.
Okay.
Mom wouldn't pay.
Okay. Well, anyway,
Very cheap back then.
Planet 1 is Tatooine. Okay. That sounds like a Star Wars thing. I've heard that before. Okay, let's see. So the URL of a planet resource, planet that this person was born on or inhabits. So okay, well, I wonder what's a Star Wars character that was born on Earth? Does anyone know that offhand?
Luke Skywalker.
Tim does.
No.
I haven't seen it.
Tim,
Was it? No.
none.
I was gonna say.
Isn't
Oh.
it like, you know,
I
not
couldn't
here?
Really? None?
That's like the point.
Okay, maybe. Well, the thing is, it's a really bad exercise. I swear I did something and I got back data for this. Because like I saw Earth in there somewhere. I thought it. Wow. Okay, so I must look really stupid right now. Pick Tatooine. Okay, yeah, Tatooine. I like that. I like that. Okay, so if we did Tatooine instead, I'm just gonna start with. I'm just gonna try just this. Okay, that still doesn't seem to work. We still get 87 back. Maybe like this. No, it doesn't seem to do anything. Maybe just like 1, because it's the planet with 1. No, it doesn't seem to do anything either. Let's see. See if we can find an example of filtering somewhere around here. But you see, like, this isn't the kind of thing where I just get it right every time, too. Like, everyone struggles with this stuff. It's never easy.
That was a huge important lesson.
Maybe I'll just search for, like, filter. Oh, they have a search. Maybe we should try, like, search. Search. You spell Tatooine.
Tattoo, I-N-E.
No. I'm gonna cheat. Copy that. What? Tatooine. Okay, well, that didn't do anything.
Does it have to be in the quotes?
We can try that. It's a good idea. Let's try. Well,
Get URL.
this is asking for a list of people that have a home
Sure, but
world.
you want the ID, right? I don't know how you would find it. It's a
Yeah, it's a good point. Yeah, maybe we need to specify the ID as the search parameter. So maybe, yeah. And I just happen to know here because we went to planets 1 that the
Right.
ID is 1. So let's try that. I think we might have already done this before though. Can you give me an example of someone that wasn't born on Tatooine?
Obi-Wan. Or
Okay.
R2D2 wasn't.
Okay. Okay, so we got that. People. Yeah, let's do this. Star Wars API filter resource. Good old Google. Okay, Star Wars API. Yeah, that's for sure. Okay, here's another thing. You guys can feel free to do research in parallel on your own if you want, but we're gonna figure this out. We're gonna figure this out.
I can't even think of another planet.
Okay, this is
Where was the bar?
someone who so
Oh,
interesting.
no, that's me. Cantina, was that a planet? Was that just the name of the bar?
Naboo.
Alderaan is another planet, except that it.
Naboo is one too.
Oh, yeah, Naboo.
So typing homeworld? Yeah, I was, okay. The URL of a planet resource, a planet this person was born on or inhabits. Let me try a different filter. Like, let's say try name. Or actually, gender. That's a good one because they give you a bunch of options that it can be. Just I want to see like one that works to see like how it should work. So if I do like gender is equal to male. Can someone give me a female Star Wars
There's
character?
Leia.
Leia. Yeah, great. That sounds like it's not. Yeah. Okay. So that doesn't work. Huh.
Just
So-
something terribly un-American about not knowing.
Okay. So I guess what this tells me is I just tried one of these attributes. I put them in the query string. I gave it one of the values it said and didn't filter it for me. So to me, that says I must be specifying this stuff wrong. Like the query string is not the right place for this stuff to go, which is weird. Like I think that's where I would think it should go. I thought that's where I put it when I did this originally. So this is going to be fun.
Aren't there different species? Like a Wookiee is different from an Ewok.
Yeah, there's species.
URL root for species resource.
So at this is about the point where I'm hitting a wall where I would probably just do the brute force solution, fetch everything, loop through, and just pick out the ones that have the home world that's one and be done. Like,
Okay.
so often you'll run into these sorts of situations where like you think, oh, this looks really easy, and then you do it and it's not so easy. So maybe let's do that. That's an alternative solution, and it's not a wrong solution. It's just maybe a little less efficient solution. It still solves the problem though, so let's do that. So if I were going to do that, I would need to make a request of this, and then I would need to go through this results here, and I would need to find each one that has a home world of this string, it looks like, because this is through in Tatooine, it's going to be this one. And then because there's, like if I look at Luke Skywalker, it's got that on there. Like R2-D2, it's something different. It's R2-D2, just for my own curiosity. Naboo, that sounds fun.
She was in Star Wars?
Yeah, the first two, 3. She's Luke and Leia's mother.
Wait, Luke and Leia are siblings?
Okay.
No? What?
First of all, I am not even a big.
Okay, never mind. I'm going to stop trying to understand this.
We could go down this rabbit hole for quite a while, and I'm
Yeah.
not like even the biggest Star Wars fan.
Which is really hard.
Okay. So I'm going to do it. I'm going to do it a different way because we can't figure it out. And this is like, I also want to make it known, like, this is a totally fine outcome of one of these exercises. It'd just be like, I don't know what I'm doing. As long as I'm going to accomplish the goal, I can do it however I want. So I'm going to make a request to this thing, and I'm going to get all the people. So I'm going to go do what we did before. This is big enough, by the way, right? Good? Okay.
I just realized in all of this getting ready for the interview, I didn't eat all time.
Oh, that's not good.
I'll be okay. Sorry.
Okay. Yeah. See ya.
Good night.
But so I'm just going to do what we did before, where we had our promise.then, and I'm going to get the response. This should by this point, you guys should have seen this a decent amount. Like response.text. So something like that. And yeah, there we get back all of our data there, printed out, nice and hard to read. So put that into json.parse, just like we did yesterday. Oh, oh yeah, I got to make another request. Oops. So, yeah, there we go. Okay, now it's going to print it out parse. So now we got our object form of it. Okay, cool. So this should be this. If you got through all the exercises yesterday, this should look familiar to what you ended up doing yesterday for near the end. But just as a quick walkthrough again, making a fetch call. We're storing the fetch call into the promise. We're attaching this function here to run when the promise resolves or when the request completes. And then when that request completes, we're extracting the text from inside of the response body from inside of the request. And then we're trying to get the text out of it. And we're storing that into promise2 here. And we're doing the same thing we did with this. We're attaching another then to it. And we're saying when this response body is finally parsed and is available to us, then we're going to put it into the json.parse. We're going to log it out. I'll post this in Slack when we're done here too, if you'd like.
Okay.
But okay, so we got this now. Now, what was I saying I was going to do? I was going to loop through these, and I was going to find each one where the home world was equal to this string, like equal to this thing. So I'm just going to do something like it's in a variable like data. So I'm going to need to parse that into something, parse it into a variable somewhere. So I'm going to go put it into data so I can do some stuff with it. So like maybe data.forEach, and then, data is not an array though. Data's this object. So I need to get the results key inside of there. Yeah, okay. So I need to get the results key inside of there, extract the results key out, and that's going to be an array. Once that's an array, I can loop through all the items in that array, and then I can do something with each of those items. So I'm going to go data.results. I'm going to get the results key out of it. I'm just going to log that out just to make sure that's what I think it's going to be. Yeah, it's an array. That's good. Okay, cool. So that's an array. So I'm going to go for each, and then for each of these items. You guys have used for each, I hope, before? Mm-hmm. Okay. I'm going to log out each of those items separately. So to just give me, yeah, it's going to log out all these things. Okay, cool. It's doing the same thing it was doing before, but now it's just logging out each of them. And I'm going to say maybe something like item dot, I think it was name is the person's name. Yeah, item dot name. And I'm going to do something like item dot homeworld is equal to this thing. I would say like resides on Tatooine, like that. And yeah, okay. So C3PO resides on Tatooine, true, I guess, according to this thing. R2D2 resides on Tatooine, false. Yeah, so this, I guess, he did, well, he got false. It's got false. He didn't reside.
Well, Obi-Wan is accurate. He's not from Tatooine either.
Okay. Biggs Darklighter. Who the heck is that?
I don't even know.
R5D4.
Big dark cloud.
Yeah, that's like an epic name.
They had good names.
Yeah, well, anyway, so this seems to be a solution we could use. I mean, but notice, like, we don't have a lot of people in here. What's going on there? Well, take a look here. Like, we don't have a ton of people in this list either. Like, let me collapse these and we can just see roughly how many there are. So in JSON, in a lot of these sorts of editors, you can actually collapse objects and like make it so you can just see like how many objects are in there. So that's what I'm doing right now. But
Yeah.
So-
Like 7 movies or something.
yeah, like this isn't enough people.
Characters and where are they?
This isn't enough people. And what I would say,
These Star Wars people, I don't think.
what I would,
Jar Jar,
yeah, we haven't seen him in that list.
Yeah.
but I don't use from Academy.
Oh. I don't need to be here. You're fine.
I mean, I've seen them all, I have kids, but I mean, I've seen them all, but.
Yeah, but so when I have see a list here where I don't see all the stuff in, my mind immediately jumps to paging. They're paging something. I'm not seeing all of it. I'm seeing only the first part of it.
Oh, they are. Yeah.
That would be my guess, especially because they have like count and next and previous and stuff like that. So I'm just going to see if I can make the page size really big and get everything back in one response and just not have to worry about this, because that would be really sweet. Otherwise, I have to like go through each, I have to like check and make a request and make a request. And that's a lot of extra logic. And trust me, that's the thing you want to write once and never again if you have to do it. So let's see page size or page.
Let me know if someone needs it.
I mean, like, be careful, that thing. It made some weird noises yesterday, I was afraid to post.
Yeah, it made a pop. It was definitely a safety moment.
Yeah. Scary.
It might have been because there was another extension for the clip into it.
Yeah, we took care of it. Also a safety moment. Rubber soles were very.
Very down.
What?
My car's in bed.
Okay. Yeah, so I'm just doing the Googling thing again. And in fact, I found an article that talks about how to do this exact thing with the Star Wars API.
Wow.
So it gives you basically like 2 approaches to solve this problem. One with like a, oh wait, this is in Python. Oh, okay. It's not quite what you guys want then, but it gives you this sort of idea where it like walks you through roughly how you'd approach the problem. I don't really want to do this right now because this is probably going to take like another half an hour if we have to do this, and I don't want you guys to sit through and talk about all the intricacies of paging. So I'm just going to say this is probably good enough and whatever. So, but anyway, I think this was actually really helpful for you guys because you got to see like what the process looks like.
Yeah.
And like, it's okay to just be like, I'm not doing this. I'm gonna go do something else.
Yeah, and often how these sorts of arguments work is you go to your manager and you say, you gave me these requirements. I'd rather do these requirements. Let's negotiate.
That is so awesome. Here, you don't know.
Yeah, there's a whole political piece there. But anyway, so I'll post that code I just ran in Slack, but hopefully you'll have more luck with the later exercises. I think they were a lot more doable. Yeah, like determine R2D2's birth year. That should be very doable. How many? Yeah, okay. Those other 2 should be very doable. No filters are involved for those. And just one brief thing before you guys dive into it and I start going around. The second API is the GitHub API. So you're actually going to do some stuff like creating repositories on GitHub with your GitHub account. And the third API is just one I wrote in the module5.tk thing. And get through as many of it much as you can. If you can't get through it, that's fine. But just use these as leading questions. Immerse yourself in it. That's really the important piece. So anyway, have fun.
Mind if I run across the street?
Oh, no problem.
I have to get my car off the loading dock.
Where do you
Yeah.
go?
Chauncey.
Oh, Chauncey's is good.
Is that quick?
Yeah, generally.
Is it pricey?
Yeah.
It can be.
It's
Bar parking.
It's bar food.
I don't think Panini's is still open across the street, but if they are, that's also a good place. No? Okay.
Now closes at like 5.
Okay. So where did you get any of my BNA part, or were you in the interview the whole time?
Oh, yeah, that's right.
I don't think I got like the meat of it.
Okay. I guess,
I love
can
that
you,
necklace. My eye is
take
drawn
day
to the
7.
necklace. It's very
See, it
pretty.
matches my jacket.
Yeah, and it also matches.
That's,
your
you're a little too
computer.
far.
A couple of your
Oh,
things.
no, I like
Monday,
these colors.
Yeah.
Yeah, I'm right.
Oh, that's day 8. Yeah, so this is the last slide of what we did
Did you
today.
have fun?
No.
Right.
Yeah.
It was okay though.
Do you have 2 days?
It was,
I have day 8 in there.
I
I don't have much beyond that, though.
Yeah, for sure.
I have some work to do this week.
You have 2 days?
Oh, yeah, I'm not gonna do that. That used to, day 8 used to be day 9. I decided I don't want to do this, so I'm making day 9, day 8, and getting rid of the second day 8.
Oh, gosh.
Yeah. This overlaps with the Nexus module, and I was thinking about it, I don't want to, it's easier if we don't start teaching the same stuff, like I'd rather do that,
Okay.
you know?
Oh, this is what you're gonna.
Yep, yeah, so I guess,
Wow.
yeah, there's a lot of words, I'm sorry.
No, that's good.
Do you want to take a look through it on your own, or do you want to go through it together?
Yeah, if you got time in it. Okay.
Yeah, that's fine. Cool. Let me actually see if I can get Anna over here, because she was missing part of it too, I think.
I think, Dana, do you need to see any of the?
Excuse me?
He's gonna go over the slide. Anyone else
Oh,
want the slide?
yeah.
Really, I think it's just a generic, right?
Yeah,
The partial
I
match,
was-
so like, we're gonna do third, so I guess. But it's like,
Yeah.
yeah, which is-
Over here.
like, equal or equal, I guess.
Yeah. So it's at the top, search is like, there's a bunch of search fields. But then,
Prepared with the academic CV.
Yeah, okay, so don't,
I'm sure it
Just
does.
looking at like, what?
Okay.
Like, this is the, they have
Yeah.
like more third advanced thing, and it's like.
Yeah,
already used.
I'm just gonna say
Yeah, I guess they just did.
There's nothing
yeah, it looks a lot like that page in format at work.
there isn't one.
Oh, wow. I didn't know that.
Yeah. But,
Yeah.
They're like, this
I mean-
wasn't the tech. We're like, yeah, I got this.
And you
I
know, all the
think-
tech
like,
stuff that I had, I like found my way to go on this really long
Yeah,
range.
server stuff is on
Yeah,
that.
The server's what? I'm like, yeah, I really gotta figure out.
Wait,
how
on
to
a random
stand on that. One of my
Yeah.
former bosses.
Yeah, well,
I don't know, like,
Yeah,
really,
she
really
is,
kind of
because
like,
I wanted to stay in that job,
Yeah.
but she made it
Also,
so
I don't know
for me, and I'm still mad about it.
I guess.
We did.
well, people not that simple queries.
Sure.
But if you
Oh,
want to
and
do
that's.
anything complicated,
So,
Well, we talk about that on the side.
Damn, that sucks, I'm sorry.
I'm not doing that. In fact, my coworker mentioned.
It is what it is. I gotta,
So, I might send.
but I need to put a positive spin on that, but I think of the real thing. You know what I mean?
Anyway.
Did you do it?
welcome
Did
to
you go through these questions?
Mhm.
I have trouble hiding out, I really feel, so sometimes I just can't talk about certain things.
Mhm.
That's what I did, I skipped.
Yeah.
Tired.
So you guys missed the part of one of that.
Better I skip it, because it might come out of my mouth.
I don't know.
Yeah.
Are you using Carla?
Dana said she's gonna.
Yeah.
Oh, yeah, that works too. Cool.
All right, I've always got you. Yeah.
Yeah, you will be thinking about the leave.
Wow.
Thank you very much.
Oh,
What's going on?
should we use this by the screen?
I mean, we can do that, or I can bring my computer over here, or we can do whatever.
I'm just trying to make sure everyone can see.
Okay, maybe I'll put my computer up here, and everyone can switch my computer.
I'm gonna pause
No,
the,
and then like
I think Karen's
Yes,
on the
that's
stream.
right.
I'm gonna pause that. Yes.
Bring a lighter.
I'm gonna pause the stream and I'm gonna use my computer for something else in the meantime, but continue with the exercises. Anyone on the stream?